Every process varies. The real question is whether it varies the way it always has, or whether something just changed. A trend chart tells you where a process is heading. A control chart asks something sharper. Is the process stable? The whole idea rests on splitting variation into two kinds. Common cause variation is the inherent jitter of a stable process, countless tiny influences you can't chase. Special cause variation is different in kind, a worn tool, a bad batch, a drifting sensor. That's a signal worth investigating. A control chart tells them apart. It plots your measurements in time order against the center line, the process average, and control limits set 3 standard deviations above and below. Stay inside, scattered randomly, and the process is in control. A point outside is a flag. And one crucial distinction: control limits come from the process itself, while specification limits come from your requirements. They are not the same thing. When measurements come one at a time, you use the IMR chart. The individuals panel plots each value. The moving range panel below estimates the spread from the difference between consecutive points. Here's conductivity. When it creeps upward and a point pierces the upper limit, Stratum recolors it. The signal is impossible to miss. When measurements arrive in batches, you subgroup. Each lot here holds several wafers. So on the X-bar chart, I set the subgroup to lot, and Stratum plots the average of each lot. Averages are tighter and more sensitive to a real shift. Alongside it, watch the spread. The dispersion picker decides how it's estimated. Range tracks the within lot high minus low, while standard deviation uses the full standard deviation for bigger subgroups, and auto chooses for you. Always read the spread chart first. Next, we chart counted data, defects and particles, with attribute control charts.